Tonight is November the 6th, 2022, and I'm going to show you something that was a project some time back. I don't know if I've shown this at all on my YouTube channel, but I'll show it right quick because at the moment it's about to be disassembled. What this was supposed to be, and is, but it just doesn't work worth a hoot, is an SET stereo amplifier. This is the input driver. 6S77 drives the 6L6 to get the voltage up high enough to drive these SV572-10s. They are sold as the cat's meow of a high-end triode. They have a gain of about 10. I think the sheets say 9.5, which is kind of irrelevant. So it's 10. And they are choke loaded. These are custom wound chokes from my good friend in Poland. Bought them and he shipped them to me a year or two ago. And then I used these little UTC transformers as an impedance matching device so I can get 8 ohms out of it, because this tube is loaded into this transformer, this choke, so it's going to be high impedance, so I got to have an impedance transforming device, which is this one for the left channel, and of course this one for the right channel. Left and right channel. This is left and right channel for stereo, and here's the inputs over here. Left and right. Red is always right. Gain controls. It's got a massive power transformer. I wanted some color in this one, that's why I painted it blue. I think that's like about an 800 milliamp transformer. It is absolutely massive. Here's the back of it. Speaker output. I think this is on and off. And this one, as I've done in another SET amplifier, I make it so I can have a little bit of negative feedback or no negative feedback. And here's the other channel, and of course the IEC AC plug, so that you're not dragging around that power cord and a fuse. Well, besides just being very, very heavy, these tubes run screaming hot. You can see actually a little bit of orange in these graphite plates. On the back side of one of these, I turned it over, I got it against this right here. It's sitting on where it was burned, and it just melted the rug to it. Well, these chassis are like $95 a piece nowadays. You know, just blank chassis. They don't come painted. I guess you can buy some painted. But that's the philosophy, the design, whatever you want to call it, of this amplifier. I want to show you underneath it before I disassemble it. I think I'm going to disassemble it. I could change my mind any moment, but I'll tell you what. Well, before I go there, what I'm thinking about doing is removing this, and this. These will remain the same, although they'll be unwired underneath, and this will be a left channel Williamson. This will be a right channel Williamson, and over here I'll put another tube, and I'm going to run these guys right here. Look at this. I'm excited about these. About 10 of these beauties. I wasn't paying attention. I thought they were 1614s, which is the old original 6L6, but these are 1619s. Look at there. Look at the date on them. 1943, right in the middle of World War II. These things are beautiful, and what they are is they're pretty darn close in power output. They'll do 37 watts in push-pull, but the unique thing about them is they are beam power tubes, but they're obviously a very early type of beam power tube, and they have a 2.5 volt directly heated cathode. 2.5 volts at 2 amps each. So this was going to be one channel, 2 for the left channel, 2 for the right channel, and I got some spares, of course. I even wound in a special 2.5 volt per channel. See, 2 wires here for one channel, 2 wires here for the other channel. This was just an inexpensive 12 volt outdoor lighting transformer that I took apart, and that goo that you see on there is shellac to keep it from buzzing. It's actually very quiet, and it does provide just a little over 2.5 volts at 4 amps. So I've checked all that. This works. Oh yeah, by the way, see that little solder blob right there? That's one of those fuses that they put in. See, I jumpered it out. That's one of those fuses they put in a lot of stuff nowadays, so if it gets too hot, that fuse opens up. And that's the end of the entire device, because not everybody knows what it is or how to even jumper it out. It's a safety thing. It's to keep from burning your house down. Not a bad idea. But sometimes when you think these transformers are open, it might just be that little thermal fuse down there. It's sensitive to the heat of the transformer, and of course the current too, I'm sure. But that's the filament transformer that I wound for it. I haven't settled on the power transformer, but I'm thinking about this guy right here. It's a monster. I like plenty of current. You want the voltage to be about what you want it to be. You know, you can go maybe plus or minus 5%, maybe even 10, depending on what you got to deal with. But I like a lot of current, and I want at least 400 milliamps. I'm sure this one's, I've written it on there, is 400 milliamps. Yeah. I'm not sure where I came up with that spec. Maybe I tested it, who knows. Let me show you underneath this thing before I most likely disassemble it. It just doesn't perform worth a hoot. And I'm going to say another thing. You know, not necessarily the highest, absolute best performing amplifiers on the workbench sound the best. That is not necessarily true. I've measured amplifiers that are stellar, just miraculously good, and they just sound sterile. Anybody that likes an SET amplifier, a single-leaded triode amplifier with no negative feedback, is certainly not interested in how it performs on the workbench, because its performance is actually quite horrible. It certainly is not a 0.5% from 20 hertz to 20 kilohertz, which is kind of our benchmark, you know. That's just an absolute fact. The output and the harmonic profile of an SET amplifier is basically that of a sawtooth. A triangular waveform. I think it's triangular. It is. You've got the fundamental, and then down just a little bit you got the second harmonic, down a little bit more you got the third, down a little bit more you got the fourth, fifth, sixth, seventh. So it's the harmonics of a SET amplifier look more like this. Here's the fundamental, here's the second, here's the third, here's the fourth, the fifth, and so on. You've practically, it's not really straight, but you've practically got a straight line. On a push-pull amplifier, this is the baseline. On a push-pull amplifier, you've got the fundamental frequency and the second harmonics down here, way down, which is actually the most important. And the third harmonic actually might be a little bit higher. And then the fourth, these even harmonics are really suppressed, fifth, sixth, seventh. So you see the harmonic profile, and this is in logarithmic form too. So this is, as far as actual analytical performance goes, much better than this. But for some reason, I am too, we're charmed by this sound right here. So all of this insanity that we make out of, you know, THD and all that kind of stuff is kind of interesting. Let me show you something else. Here's a really interesting little quirk about these tubes. If I can get this thing to focus. See, that says it's an SV572-10. Well, I ordered these a few years back from a good fellow on eBay. Very, very good seller. I don't remember his name. But they were advertised and sold as SV572-160s. This 10 and 160 and so forth. There's one that's a 3, a 10, a something else, and a 160. The 160 is the same gain as an 811A, and that's what I wanted. And that's what the box said when they got here, so I didn't think much about it. I remember testing them, or just lighting them up, and one or two were bad. He sent me some more immediately. And then they laid around for a while, and for some reason, then I picked them up and I looked at the tube itself, and it's a 10. But the box says 160, so the whole thing, everything was sold as if they were 160s, but I actually got 10s. Now you're going to ask, well, how do I know they're 10s and 160s? Well, actually, I don't for an absolute fact know that they are 10s, but I don't know if you can see this or not, but if you can see down inside this tube at that grid, I can't point at it because I only got 2 hands, but if you can see where the grid is in there, you can tell that this is not a 160. Let me show you this. Most of you, many of you may know this, but some of you may not. The grid of a low gain tube is wound like this. I'm exaggerating just to make a point. There's a lot of spacing between the wires. The grid of a high gain tube is wound like this. It's very, very, very closely wound. So you can actually, if you can see inside of it, and you can compare to, you can actually learn how to differentiate by looking at it, by looking at the grid. Again, if you can see it, some you can see and some you can't. The difference between a 12A-X7 and a 12A-U7. Now, the 12A-X, T, U, Z, Y, all that kind of stuff, they're all slightly different gains. But the 12A-X7 has a gain of 100. And the gain of a 12A-U7 something like 40 or 50. Don't remember. You guys can set me straight on that. But you will actually see that the grid of a 12A-X7 or any high gain tube is wound with very fine wire, very close together. And it only makes sense because you got the cathode, you know, right in here. And it's trying to get electrons out. Let's don't get in an argument whether they go from plate to cathode or cathode to plate. The way that I've always looked at it is in engineering, you think about everything flowing from positive to negative because that just makes it convenient to figure out. In physics, you think about them flowing from negative to positive because of the abundance of electrons in negative, and it's the flow of electrons, so it must be flowing from negative to positive. It doesn't really matter which way you figure it out as long as you stay consistent. You can't figure half of it out one way and half of it out the other, and you'll end up with a wrong answer. But, you know, whatever procedure you like. But anyway, if you've got a very coarse wound grid, the electrons flowing off of this thing past that grid, which is influencing it by its bias. This one's going to take like a minus 100 volts bias, for example. And this one's going to take either 0, depending on just how close it is, wound, like the big IMAC transmitter tubes with a gain of 200, like the 3500Z, 3400Z, 31000Z, they have a gain of 200. They have such a tiny openings between. Actually, I think the grid in it is built like this, with the filament inside, and I think there's just holes in the side like that. So it makes for a very, very, very high gain tube. But it kind of makes sense. It is one of these rare common sense things that it's going to take a whole lot more negative bias on a coarse wound grid to restrict the flow of current, you know, in between them, because it's flowing out of here over to the plate. Right, the electrons are trying to get out, and they're not trying to go through the grid, but they're trying to go, you know, in between the grid windings. So anyhow, just thought I'd throw that in. These are definitely a low gain tube. Instead of 10s, they could have been mislabeled again. They could be the 3s. That I actually don't know. But I hope you can see that grid a little bit. You can see it's pretty coarse. So that is my thoughts at the moment. Let's see what I'm going to... Oh, yeah, you got to look under this, though. I think it's quite beautiful. But it just doesn't perform very well. It's enormously hot. There's 1,000 volts on the plates of those tubes. And I just can't justify this monstrosity for a few watts of SET sound. Okay, well, power supply choke. See, this one is 1.5 Henry's, 500 milliamps. Like I say, I like high current devices because you don't end up with so much voltage drop across them under load. Because you can lose quite a bit of voltage across your chokes if they're too small in the current rating. In my opinion, it's better to have a 1.5 Henry 500 milliamps than a 10 Henry 200 milliamp. Well, 200 milliamp wouldn't work in this one. And if you look at the specs on, say, the Dynaco amplifiers, they've got 1.5 type value Henry chokes in their And there were amplifiers. Here's another one, because this is the plate load for this 5881 over here. I wanted to make all of the load inductive. And this separates the DC, so there's no DC flowing through this transformer. And this is a balance, I believe. I don't remember, yeah. Or it's gain control or something. This is a hum balance. When you use directly heated cathodes, you do not have to put DC on them. Putting DC on your filaments does not ensure that you do not have hum. What you need to do is you need to put like a 50 ohm resistor like this. See how it's across it, and this part right here goes to ground. Or if not to ground, it goes to the, actually they go down to here to this cathode bias circuit. Maybe it could have been better if I'd have used fixed biased. Same thing up here. Here's the other channel, coupling capacitors. See, as you can see, they're pretty much mirror images of each other. Here's the capacitors, the left and the right capacitors for the power supply. Notice that I do put them up. See that brown insulation in there? It's not a good idea to put these things to glue them. I use goop or some kind of silicone stuff. It's usually not a good idea to put these directly onto the chassis, because I have had them arc through. So I put them up on some insulating material. See, same thing up there. These right here don't look like they're on insulating material. I don't know why. They must be down at the low end where the voltage is really low. Some of these things, some of these capacitors, most of them I think come with a piece of plastic on the bottom, which will help. But I've had it arc through. And this is some other hum balance or something of another, I don't know. So, it turned out looking nice, but like I say, for what it is and what it does and what it weighs and how hot it is and everything, I'm continuously talking myself into getting rid of it. You always want to use a common ground point for your power supply. You actually have some pretty heavy currents flowing through these chassis. A good example was years ago when I built some amplifiers for a friend. She sent me a chassis that are very, very nice. They're actually quite expensive. But they, the panels here, the side panels, you know, the front, side, back, and other side panels are not part of the top. See, this is all one bent chassis. You know, where it's a folded chassis. And what I had on one of those amplifiers is I had arcing between this chassis and this chassis because they're just stuck together mechanically. So what I had to do is I had to start putting some jumpers, you know, a ground terminal right here and then another one right here. I had to actually electrically connect the panels, each one of them, to the top chassis, which would make that chassis absolutely unusable for RF. I wouldn't even get close to that thing for radio frequencies. Just thought I'd throw that in. Yeah, they were very good quality chassis, very nice thick aluminum, much thicker than these. I have found out that when you build really big stuff on this, things that weigh 100 pounds or so, these chassis do want to flex a little bit. I had that problem with some of my modulators. Not exactly a problem, but a concern. So the next time you see this beast, let me set this back down again. The next time you see this beast, actually all that'll be missing from the top is this, and the underneath will be cleared out. And I've been thinking exactly how to align these tubes. See, I have these in line and I have these in line, so if I put another one over here right there, but this distance between these two, between the channels, is different. If I put the other tube right here, that little screw right there may be sort of in the way. I don't mind a couple of mystery holes, because I fill in mystery holes with extra screws and stuff. A few extra holes is really not a terrible thing. I mean, even Even the most famous paintings in the world, I believe, are oftentimes painted over things that had been painted before, because, you know, the price of canvas back in, I don't know, 1492, I guess, was kind of expensive. I don't know about those dates and what have you. I'm just making a point here that reusing chassis, at, like I say, at the price of these things, is not an altogether bad idea if you can get away with it. And sometimes the holds, of course, are in the right place for other things, and that means I don't have to rebuild this. I don't have to rebuild the back panel. I don't have to cut all these holes and mount those big transformers. Okay, let's talk myself into it. So I may actually move this one a little bit further out, and this one a little bit further out, maybe just, you know, not exactly in line with this over here, and that'll move it away from these screws. Well, there you go. That's what it is. And but I'm just really charmed with these guys. I hope they work out the way they're supposed to. Thanks for watching. Stay safe. One last thing. This is the amplifier I listened to now. I made a video about this one not too long ago, and there it is with this MV rectifier. Works really good. Don't have much of a speaker out here. It sounds kind of tinny on the speaker I have. But if you guys have any thoughts on this right here, there's no write-up that I know of from 1943 or before about how to use these tubes in a triode connection, which means running the screen grid at the same plate voltage as the plate, which is what I prefer to do, because if I run the screen and the plate at the recommended value, then I have to build another power supply, or at least, you know, somehow devise another power supply. Doesn't mean I have to make another transformer, but it does mean I have to do some voltage dividing in here, which the screen current shouldn't be anything terribly significant. Good example is the 6L6. The 6L6, if you look at its original ratings, they always lower the screen voltage on it, and that's the way to get the most amount of power out of these beam power tubes, but it also makes it a little bit more complicated. So I think what I'm going to do is just strap the plate, the screen to the plate through about a 100 ohm resistor. I found out if you put tubes parallel, especially like 6L6s, 1625s, 807s, 5881s, KT88s, etc., you should actually not strap the screens directly together. You need to put like a 100 ohm resistor off of each one, because I don't know exactly why, but I have made an amplifier. I think I posted something on it some time back that had 4 807s in it. The 1625s, I believe, is the 12 volt version of it. That's what I was running, and I had some very difficult problems with it until somehow I got the idea that maybe I'd read that somewhere way back when, to give the screen grid kind of some space. And when I put, I believe, 100 ohm resistors, it didn't take much. Probably even use 1K. There's probably a pretty big range. It settled right in and worked so much better. There's just something about that screen grid that's very important. So that's just an extra thought there.